Welcome back to The Explainer, everyone. Today, we're totally decoding the invisible world of networking that's happening literally all around us. I mean, we rely on the internet for absolutely everything, right? But the underlying rules governing how that data physically zips from point A to point B, yeah, they're wildly misunderstood. So we're going to strip away all the heavy jargon and look at the actual real-world architecture of IP communication. Let's get right into it. Okay, let's dive into this. It's kind of a paradox we experience every single day. Have you ever wondered how exactly your laptop instantly finds your wireless printer, but at the exact same time, both of those devices stay entirely hidden and totally protected from the wild, chaotic traffic of the global internet? Well, it's all thanks to a pretty elegant system of boundaries. Here's our quick roadmap for the explainer today. We'll start with the anatomy of IPs, then cover the rules of direct communication, look at the difference between private and public worlds, and finally, bring it all together with the apartment building analogy. We'll be scaling from the inside of a single computer all the way out to the global internet. All right, Section 1, the anatomy of IPs, breaking down the address. Let's see how every IP address actually leads a bit of a double life. To really get networking, you first have to realize that every IP address is strictly split right down the middle into two crucial halves, and each half has a totally distinct job. We've got the network part and the host part. Think of the network part as your neighborhood. It essentially tells the routers exactly which local area your device belongs to. Meanwhile, the host part, that identifies the exact unique device living inside that specific neighborhood. And this brilliantly illustrates how we can map those abstract technical terms right onto something we all know, a physical mailing address. The network part is exactly like the street name on a letter. It gets the data to the right general location. Then the host part is your house number, making sure the data actually gets to your specific front door. I mean, you can't deliver mail with just a street name, right? And a house number is utterly useless if you don't know the street. You absolutely need both to communicate. Moving right along to Section 2, rules of direct communication. Let's look at how devices actually talk on a network. So now that we know how an address is built, how do these devices communicate with each other? Well, for two devices to engage in what we call direct talk, meaning they're communicating locally without any outside help, they absolutely must share the exact same network part, but have different host parts. Basically, they have to live on the exact same street, just in different houses. But if those devices have different network parts, communication fails outright. They're on entirely different streets, so they're going to need a bridge. Consider this your strict technician's warning. If you're ever wondering why two devices just won't see each other on a network, check those street names. If the network parts are completely different, those devices are totally invisible to one another. Zero direct connection. The only solution to bridge that gap is a router, which you'll often hear called a default gateway. It essentially acts as the busy intersection connecting two completely different streets. Let's move to Section 3 and see how this builds. Private versus public worlds, local and global addresses. As we zoom out from just a single local network, you'll see these addresses are fiercely divided into two very distinct worlds. First up, we've got private IPs. These are used inside your local home or office network. They are completely free, totally hidden from the outside world, and strictly meant for local talk only. But here's the catch. They can't access the internet directly. To do that, you need public IPs. These are assigned by your internet service provider, and they act as your router's outward face to the global internet. So the crucial point here is what we call the global rule. Every single device on the internet must have a completely unique public IP. Literally no sharing allowed. Inside your house, you can totally reuse the exact same private IP addresses your neighbor uses because they're completely hidden. But out on the global web, absolute uniqueness is strictly enforced. Think about it. If two routers had the exact same public IP, the internet would have absolutely no idea where to deliver the data. Which brings us to our final piece, Section 4, the apartment building analogy. Let's bring all of this together. Now, what's really interesting about this concept is how cleanly it maps to everyday life. Think of a massive apartment complex. Your private IP, that's your apartment room number, let's say apartment 4B. That number is a local identity. It's hidden safely inside the building. An external mail carrier driving down the road has absolutely no idea where exactly room 4B is, and honestly, they don't care. They only see the public IP. The public IP is the main physical street address of the entire apartment complex. It's the single, unique face of the building presented to the outside world. So what actually happens when you sit down and open a web browser?
Well, in step 1, your laptop generates a request using its hidden private IP, your internal room number. In step 2, that request hits your router. Your router is basically acting as the front desk concierge of the apartment building. It intelligently strips away your private IP and swaps it for the building's main public IP. Finally, in step 3, that traffic enters the global internet, fetches your website, and comes back to the router, which then perfectly routes it back to your specific room. And this crazy translation, it happens literally hundreds of times a second.
So we've scaled from the inside of a single computer all the way out to the global internet, and you now have the solid blueprint for how it all communicates. But consider this. If the absolute global rule is that every single outward-facing device requires a completely unique public IP address, what happens when our increasingly connected globe finally runs out of addresses? It's a massive engineering hurdle, and it changes the landscape of networking entirely. Master these boundaries, though, and you master networking. Thanks so much for joining me on this explainer today, and I will see you next time.